Hi everyone. In today's lesson, we're going to talk about the unit circle. A unit circle is a circle with a radius of 1 centered at the origin. So if you take a look here, this is what an exaggerated unit circle is. Why I say the word exaggerated is because technically, if you were to, graph a circle with at the center at the origin, and then a radius of 1, you would go 1 to the right, 1 up, 1 down, and then 1 below, and you'd connect your circle. So that's a really small picture. So what we do is we still have the origin here, but we just exaggerate that we went over a little bit so that it's clearer to see. So we're going to go over 1, up and down, nothing. That's how we get the point 1, 0. Then we're going to go left or right, nothing, 0. And then right up 1. That's how we get this point. We're going to go left 1, -1, and then up and down, nothing. And then here we're going to go left or right, nothing, 0, but then down, -1. So these are the 4 points that make up a circle with a radius of 1. So what we could also do, instead of having a radius going from here to here, right? A radius is half of the diameter, so from the center to one of the points. We also could say have a radius go from center to this point here on the unit circle. So we're going to call this point x comma y. And we're going to discover some things about that point. So let's just talk for a second. Do we agree that we went over x and then up y just to get to this point? So what we could do is drop down this perpendicular and label our pieces. So from here to here, I went over the x amount, and then I went up the y amount to get to this value. And we can label our radius of 1, right? Unit circle has a radius of 1. So this is my radius, and then those are the dimensions of my triangle. So now let's analyze what we did. So we know that cosine is adjacent over hypotenuse. So first, let's put our theta. So theta always goes in the middle, right, by the origin. And let's label the information. So with respect to theta, the 1 is my hypotenuse because that's directly across from this 90-degree angle. The y is directly across from the theta, therefore that will be my opposite side. And the adjacent side would be x, right next door to my theta. So let's analyze what cosine is. So cosine is adjacent over hypotenuse. So adjacent x, hypotenuse 1. So we can conclude that cosine is x divided by 1, which simplifies to x. Now let's do sine. Sine is opposite over hypotenuse. So opposite is y, hypotenuse is 1. So y divided by 1 is simply y. So sine of theta is y. And now let's do tangent. Tangent is opposite over adjacent. So opposite y, adjacent x. So y over x. And if we know that the y value is sine and the x value is cos, we can say that tangent of theta is sine theta divided by cosine theta. So these are the 3 main conclusions that we get from the unit circle. So technically, we can say this point, x comma y, is the same thing as saying cosine of theta, comma, sine of theta, right? Because x is my cosine, so if this is x, this is x. And then if y is my sine, then y is my sine. So any point on the unit circle, the conclusion is that it's going to be cosine of theta, comma, sine theta. So let's conclude all this out now. So we've just concluded that sine is our y value, cosine is my x value, tangent is the y over x, or in other words, sine of theta over cosine of theta. Now, since we know sine, cos, and tan, we can conclude cosecant, secant, and cotangent. We know that cosecant is the reciprocal of sine. So technically, we know that that means to flip it. So technically, we could write y as y over 1. So if we flip that, it just becomes 1 over y. And we know that y is sine, so 1 over sine of theta. Either one of those is fine. We knew that secant is the reciprocal of cos. So if cos is x, we can make this x over 1. And if we flip that, that becomes 1 over x. And x is cos. So we know 1 over cos. And then cotangent, we know is the reciprocal of tangent. So we can go ahead and flip that. So that's going to be x over y, which in other words is cosine of theta over sine of theta. So what I'd like to do now is move on to the back page so that we can use all of these conclusions and see how we can use it in a problem. Okay, so we need to use the unit circle to determine quadrant angle measurements. So before we even do that, let's label our diagram. So we know that this is 0, 90, 180, 270, and 360. Now, it would be helpful if you memorized the radian conversions. 90 is equivalent to pi over 2 radians. 180 degrees is equivalent to pi radians. 270 is equivalent to 3 pi over 2 radians. And 360 is equivalent to 2 pi. 0 in degrees is also the same in radians. So 0 degrees is 0 radians. So now let's see what we can do. I'm just going to make this a little bit smaller so we can see it all on one page. So we need to figure out the value of sine of each of these angles, then cos of each of these angles, and so on and so on. So I'm going to do the first column, maybe the second column with you, and then I'm going to leave you to do the next 2 columns for homework. So sine. We know that sine is the y value, so we can go ahead and label that as the y value. So if I want sine of 0 or 360 or 0 or 2 pi, all I'm going to do is look at the y value at that angle measurement. So if this is the angle, we're going to look here at the point and at the y value. So the y value is 0. Then we're going to do the same thing, but for cos. So we know cosine is the x value. So I'm going to look over here at the same angle measurement. So at 0 or 360, my x value is 1. And then if I want to find tangent, we know that tangent is the y value divided by the x value. So the y value was 0 and the x value was 1. And 0 divided by 1 or 0 divided by anything will reduce to 0. Okay, so now the next are the reciprocal pairs. So cosecant of theta. We know that cosecant is the reciprocal for sine, right? These two are reciprocals. So if sine is the y value, we can say that cosecant is 1 over the y value. So if the y value is 0, we're just going to say that it's 1 over 0. But we have to remember, if 0 is in the denominator of a fraction, we say that that means the fraction would be undefined. So this answer for cosecant would actually be undefined. Now, secant. Secant is the reciprocal of cos. So we know that that means it's going to be 1 over the x value. And since the x value is 1, it's just going to be 1 over 1. And 1 divided by 1 is simply 1. And then the last one is cotangent. So we know tangent and cotangent are reciprocals of each other. So the reciprocal would be x over y. So the x value is 1 and the y value is 0. So 1 over 0, again 0 in the bottom, would make this undefined. All right, let's see if we can do the next column together. So pi over 2, which is 90 degrees. So all of our information now will be based off of this coordinate point 0, 1. So again, if I want to find sine of 90 degrees, we're going to look at the y value. So the y value is 1. Cosine of 0, we're going to look at the x value here, which is 0. And then tangent, we're going to divide the y value and the x value. So the y value is 1 and the x value is 0. So 1 over 0, we know that that has to be undefined. Now cosecant, we're going to take the reciprocal of sine. And if sine is 1, we're just going to do 1 divided by 1, which is 1. Secant is the reciprocal of cos. So if cos is 0, it's just 1 over 0, which again would be undefined because 0 would be in the denominator. And then cotangent is simply the reciprocal of tan. So if it's 1 over 0 for tangent, we're going to make it 0 divided by 1. And 0 divided by anything is 0. All right, excellent. So what I'd like you guys to do now is try column number 3 and column number 4 for homework, and we'll touch base there tomorrow. All right, have a good night.